We are going to be studying the periodic table and what it means. Periodic table really just shows us all of the different types of elements in the universe. And we are really identifying new ones all the time. So right now we have 118 identified elements in the periodic table, but it's always changing. And remember, an element is made up of the same type of atoms. So it's oxygen would be an example of an element. It's made up of only oxygen atoms. Neon, made of only neon atoms. Helium is made of only helium atoms. So it's a pure substance, so we can consider it. Element made of only one type of atom. And the periodic table of the elements lists all of the known elements in the universe. Some of them are synthetic, they're man-made, some of them are natural. When we look at the periodic table, though, the first thing we're going to talk about is the information you can get about the individual element. So if we look at helium, for example, if I were to zoom in on helium in the periodic table, okay, so the table is made of those boxes, and I'm looking at helium, and this is what I see. But I can get a lot of information just from this. First thing I can get is the chemical symbol of the element. So the chemical symbol of helium is He. And that is either going to be one letter or it's going to be two letters. If it's one letter, that letter's always capitalized, like oxygen, for example. Uppercase O. Iodine, uppercase I. If it's two letters, the first one will be capitalized and the second one will not. This is important you know this because when we balance equations and look at chemical formulas, you have to know if they're different atoms or if it's the same atom. So He is the chemical symbol for helium. So that's the first thing we can tell from the periodic table. So the chemical symbol is really the abbreviation for the chemical element, and it doesn't always start with the same letter of the element. In this case it does. So this is helium. That's the chemical symbol. So right here. The next thing we can tell from periodic table is the atomic number. And that's this number above here. Now, there's always going to be two numbers for each element here. The smallest one will be the atomic number. Usually it's written above the symbol. So this is the second thing, atomic number. And what does the atomic number mean? It's the number of protons in that atom. And this is really what makes these elements different. All right, so the main difference is just the number of protons in that atom. If you add a proton to oxygen, it's no longer oxygen. It's fluorine. All right, so if you add a proton to hydrogen, it's no longer hydrogen, it's helium. So the proton number is what makes the atoms different, and that is called the atomic number. So it's equals the number of protons. Now remember some symbols here for protons. P, positive. Now, also think about atoms. Normal atoms, most of the time, are neutral, no charge. So that means the positives equal the negatives. So the positive parts of the atom are the protons. The negative parts of the atom are electrons. So if we know how many protons the atom has, we can figure out how many electrons it has, because they're the same number. So this would also equal the number of electrons. And remember the symbol for electron, E, negative. So we can tell that just from this atomic number we already have now. We have the atomic number, which is the number of protons, but it's also the number of electrons. So it's the same number. Atomic number. And the number below now, or the larger the two numbers, is called the atomic mass number, or atomic weight. So weight and mass are not the same thing, but when they talk about atomic mass and atomic weight, they're used interchangeably, even though technically weight is actually a force. It's measured in newtons. Weight is the effect that the gravitational force has on mass. So weight is equal to mass times gravitational force. Let's say these are protons. So we have two, because we're looking at helium. And let's say these are the neutrons. I don't know. It also has two, but we'll talk about how you can figure that out. These are both in the nucleus of the atom. They're both in the center of the atom. So, like I said before, most of the atom is empty space. But the mass of the atom, when you're talking about the mass of the atom, most of the mass then is actually in the nucleus of the atom, in the center. So most of the mass, almost all of it, because the electrons almost have no mass. They're very, very light. They're very, very small. So the mass, the atomic mass, or the atomic weight, is the nucleus. So what do we have here? We have protons, and we have neutrons. That's in the nucleus. That is the atomic mass number. It's equal to the number of protons, P plus the number of neutrons, N to the 0, so no charge. So these symbols you should know. P plus for proton, E negative, electron, N 0, neutron, no charge. So these two things are the atomic weight or the atomic mass. So how do I figure out the number of neutrons then? So if I know the number of protons from the atomic number, so I know how many are here, and then I also know the total in the nucleus, because that's the atomic mass. So all I do then is just take the atomic mass, which is all of this, and subtract the atomic number, right? So then I'm left with the number of neutrons. And in this case, they're all 2. Doesn't always work that way though. To get the number of neutrons then, if I'm looking at the periodic table, I take the mass number, the atomic mass number, or the atomic weight, subtract atomic number. And for this, you can see the atomic mass, it's not a completely whole number. We're going to round it to the nearest whole number when you do this. So 4 minus 2 is equal to 2. So that is the number of neutrons in an atom of helium. So to get the number of neutrons, you take the atomic mass minus atomic number. That's just an introduction to the periodic table.